Okay, so 6A, basic trigonometry with right triangles. So the two rules are that you have to have a right triangle, meaning one 90-degree angle, and you must have at least one angle and one side length in order to make it work. And you're going to use these to find missing lengths of a right triangle, to find missing angles of a right triangle, or to find the height of an object that is difficult to measure. So like something like a tree or a building, something that's very tall. So the first thing we're going to talk about is we're going to talk about how you can label a triangle. If you don't get the labels right and know which side is corresponding to which thing, then you cannot make this work. So we're going to talk about the labels. All right. First thing, so let's just draw a right triangle. And the orientation doesn't matter. It can be flipped over. They can be up. They can be on their side. Whatever. Doesn't make any difference. To indicate that it's a right triangle, we're going to use a little square. Okay. Remember that square in the corner always indicates I can't spell, a right triangle. Now remember, this only works with right triangles, so you need to be told that it's a right triangle. You could be told that that angle is 90 degrees, or they'll most commonly just draw that little square in the corner. Then, we'll talk about the measurements of the sides. The side straight across from the right angle is called the hypotenuse. And it's the longest side, and it's always opposite the right angle. Okay. Then you're going to be given some unknown angle, and remember the Greek letter theta is used to represent an angle. Just like x in algebra for an unknown number, we usually use theta for unknown angles, or just to represent any angle. And this side next to it is something called the adjacent side. Adjacent just means side by side or right up against it. And then finally, across from that angle, you're going to have the opposite side. So you have a hypotenuse, an adjacent, and an opposite. You don't have to write out the words, but you need to label them. So you can just use O and A and H if you want to, but make sure you label them every time you use them. We will be looking for that when we're marking these, right? That you know which side's which. Okay? All right. So once you've labeled a triangle, then you can use those side lengths to build what are called the trigonometric ratios. So let's talk about those ratios. Remember in our measurement chapter, we talked a little bit about ratio. A ratio is just a comparison of one thing to another, and it's generally written as a fraction. And the trig ratios are no different. And there are three of them that we're going to work with, but there are more. They have inverses as well. But right now we're just going to concentrate on the actual ratios. So if you have the sine of theta, again, theta just means any angle, doesn't matter what it is. The sine of theta can be found by taking the opposite side length and putting it over the hypotenuse. And that's usually abbreviated as O over H, which gives you the mnemonic device that most students use to remember these as SO. Sine, opposite, hypotenuse. Right. The next one is something called the cosine. So the cosine of theta is simply the adjacent over the hypotenuse. and its abbreviation is A over H, which gives you the mnemonic ka. And finally, we have the tangent of theta, which is simply the opposite over the adjacent, which gives you O over A, and the mnemonic TOA. So the easiest way to remember this is so, ka, toa. Lots of other mnemonic devices that you can use. There are a lot of sentences or little snappy sayings, but SOHCAHTOA is probably the easiest. If you've remembered it some other way, of course, that's perfectly fine. So what we're going to do is we're going to just look at the steps for building the trig ratios. Then we're going to look at a few examples. They're quick and easy. You'll like them. So our steps are: first, label the triangle. On most of these, there's very little work to show, which means that marking me is going to involve just being able to see what you started with and seeing what your end answer is, because your calculator can do all the work for you. You don't have to write it all out. So that means you need to be very careful when you're labeling it. So label your hypotenuse, your opposite, and your adjacent. Okay? Just make the little drawing just so that it helps you out as well. Second, you're just going to determine the values that you need for the given function. Or let's put ratio, sorry. Given ratio. So for example, if they want the tangent, then you know that means you need an opposite and an adjacent, right? So determine which ones you want and what those values are. And to get the actual values, you're just going to enter that into your calculator. You're going to see today they're just going to give you, they want the sine of some angle, and you're just going to put that into your calculator. The thing that you need to make sure, though, which you don't really have to worry about too much with your scientific calculators, is that you must be in degree mode. But the default for most of those calculators, unless you have something odd, the default for the calculators, the Casios, is degree mode. If you're using a graphics calculator, the default is radians, so you would have to change it, but only if you clear it. Otherwise, it'll just stay in the right one. All right? So those are the steps. What we're going to do is just go to the exercises and look at a few of those.